in this video we're going to talk about angle pair relationships, and there's a lot of definitions, so I hope your hand is ready. So the first thing we want to talk about is acute angles. And this is an angle with less than 90 degrees in it. And I drew an example over here. So it's not a right angle, it's going to be less than 90 degrees. Anything less than 90 degrees, but greater than 0. Next we want to talk about an obtuse angle. And this is going to be an angle greater than 90 degrees. Greater than 90, less than 180, but an obtuse angle. Next, a right angle. This is one that looks like an L. Right angle is exactly 90 degrees, and it's going to be denoted with a square drawn into it. So we have a right angle, an obtuse angle, and an acute angle, and they all kind of relate to each other. Then we want to talk about a complementary angle. And this is a pair of angles, and the sum is going to be 90 degrees. So in other words, they add up to equal a right angle. So like 30 and 60, or 45 and 45, or even 10 and 80. Any combination that adds to equal 90, those are an example of complementary angles. Next, supplementary angles. A pair of angles whose sum is 180. So 60 and 120 works, 180, any way that they add to equal 180 are supplementary angles. They don't have to be beside each other, but a lot of times they will be. So acute angles, obtuse angles, right angles, complementary angles, supplementary angles are terms that you're going to hear a lot. All right, but we're not done. Adjacent angles. Hopefully you know the word adjacent. It means beside. Adjacent angles share a side. It could be a leg or a right, and a common vertex. Now the common vertex means this point right here. Vertex is just a point, or a corner point. So I said here, like angle 1 and angle 2, those are adjacent. It doesn't have to add up to any certain amount. They're just sitting side by side. So here they're sharing this common ray, and they are beside each other. So they are what we call adjacent angles. Next we have vertical angles. Angles that are opposite of each other when two lines cross. Vertical angles are congruent, which means they are the same size. I always call them the kissing angles because it looks like two fish who are kissing. So like angle 1 and angle 2 are vertical angles, angle 3 and angle 4 are vertical angles. This is something that you will use a lot as you get into higher maths and you start doing something called proofs. But vertical angles, they are congruent. Again, kissing angles. That's how I've always told people to remember it. Okay, linear pair angles. Two angles that are adjacent, and they are supplementary. So linear pair angles, my picture looks just like it did for supplementary angles. So this time they have to add up to be 180, and this time they have to be beside each other. So linear pair angles, if we pulled out this piece in between them, they make a line. You know, a line is what we call a straight angle, or 180 degrees. So linear pair angles are two angles that add to equal 180. Oops. And they are adjacent. So I've taken two of my former angles and put them together, which is adjacent angles and supplementary angles. Then here at the bottom, this is our last definition, I promise. I just reviewed the types of triangles that you should already know. First was equilateral, and it means that all three sides are the same. These little hash marks, not hashtags, hash marks, just denote that these sides are the same. An isosceles triangle has two equal sides. These hash marks say that those two sides are equal. A right triangle has a right angle. An obtuse triangle has one obtuse angle. What I forgot was the third type of triangle that you probably already know, and that's a scalene triangle. And of course, a scalene triangle has no equal sides. So we have three equal sides, two equal sides, no equal sides, a right angle, and then an obtuse angle. So 5 types of triangles that you could possibly come across. All right, so why do we worry about all these different types of angles and their relationships? How do we use them? So let's look. So here's some angle pair relationships. How do they help us? What are these? So here I have angle A and angle B. What's the relationship? Well, hopefully as soon as you looked at this, you saw some kissing going on, and really you can see it here more than here. But if these two are vertical, then these two are also what we call vertical angles. Okay. Over here we have A beside B. We know nothing else. We don't know any numbers. We don't know If they complement, we don't know if they supplement, but we do know that they're side by side. So we can call these adjacent. Okay, we come down here. Again, A and B. We can see that if I pulled this piece out, what do A and B do? Well, they form a straight line. So we know two things, that they're supplementary, we know that they're adjacent. So we're going to call these linear pair angles. We could say they are supplementary angles, but we usually say that for when we actually see numbers. All right, now what's here? Once again, if we looked, these are vertical angles. Told you, vertical angles are really important, so I'm making sure that you can recognize them. All right, so what else can we do with all those relationships that we just learned? Surely I didn't make you do all those definitions just so you can recognize them. Of course not. Now we're going to put some math in it. So we want to find the missing angle, or missing variable. So up here, this one's 80, this one is just B. We want to find the value of V. Well, we can see it makes a straight line. We also see that they are adjacent, so they make a linear pair, or they're supplementary. So that means that B plus 80 has to equal 180. Well, we know how to solve a basic equation. If I subtract 80 from both sides, I find out that B is equal to 100 degrees. Or I could say that angle B is equal to 100 degrees. What about over here? What's the relationship? These are vertical angles, so I don't actually have to do any math. I can simply say that angle B equals 75 degrees. Okay, these two get a little more difficult. You actually have to do some work. So this side is a right angle, and it's vertical to this side. So that means that if this is 90 degrees, this is 90 degrees. This whole side is 90 degrees. So I can say that 6x plus 2, which is this part, plus 40, that's this side, equals 90. So now I just have to solve all this. So let me combine my like terms here. 6x plus 42 equals 90. Now I just have a two-step equation I need to solve. So I subtract 42 from both sides. I get 6x equals, what's 90 minus 42? Do a little work on this one. 10 minus 2 is 8. I get 48. 6x equals 48. Divide both sides by 6, so I find out that x is going to equal 8. And if I plugged it back in, 48 plus 2, I would get this part to be 50. 50 plus 40 is certainly 90. So 90 and 90, they're now congruent. Now look at this one. Also a set of vertical angles. Remember, vertical angles are congruent. So to solve for x over here, I have to set these two equal to each other. Oh, I didn't leave myself much space. I'm also going to change colors. So, to do this one, I want to do 3x plus 5 equals 4x plus 2. Again, I set them equal to each other because they are vertical angles, and we know that vertical angles are congruent. So now, I have variables on both sides. Well, we know how to do that. It's just been a while. So we're going to start with a non-variable number. I'm going to bring my 2 over so that I don't end up with a negative. So now I have 3x plus 3 equals 4x. So now let's move my variable to the other side, because remember, you want all variables on one side. So now I can bring down my 3. I get 3 equals x. So let's go back and plug it in and make sure it worked. So if I plugged in 3 times 3 plus 5, 9 plus 5 is 14. And if I plugged in 4 times 3 plus 2, it's also 14. 14 equals 14, so we're good. So this is how we can apply some of those angle relationships and use them within geometry.